Hello and welcome back to Learn It from a Layman. I am Carl Christensen. I am joined today by Cameron and Matt. Tim, we believe, has lost the battle to artificial intelligence, and we won't be hearing from him anymore. He has become one with ChatGPT.
Well, I mean, not that we endorse one over the other. He could have succumbed to either of the.
That's right. He had a few options. It's whoever offered him a little bit more money. He didn't put much of a fight, which is only tangentially related to the topic du jour, which is robotics. And we've done a podcast in the past about artificial intelligence, but this is going to be specifically about robotics, and Matt's going to tell us a little bit about the basics of robotics. So shoot, Matt.
Okay, so with that, has everybody seen Star Wars?
That's the one with like Jean-Luc Picard.
Oh boy, I can tell this one's going to go well.
Yeah, I think so.
All right. Well, okay. So first off, what is a robot? What do people understand as a robot being?
Well, I think the general layman picture is you picture somewhere between like your Roomba, like the automated machine type of get a task done, all the way up to your fully intelligent bicentennial man achieving human consciousness, fully functional android. So something that is made of non-biological substances and can interact with the physical world.
Those are good thoughts, Cameron. Cameron is taking is pondering deeply here.
Well, he's also lost to the artificial intelligence.
Okay, that's fine.
Yeah, good old artificial intelligence. I don't know. I mean, I think like the most basic thing like for robotics is the programming something with a command and it does it. So I think that's the most basic thing of a robot.
Yeah, you pretty much covered it. It is something that is set up to automatically perform some kind of task. You can have anything from a robotic arm used extensively in manufacturing to a full-up bipedal humanoid thing that people are actually trying to get to because they have seen Star Wars and for some reason they think that's cool. The military is working on robot dogs because, of course, we are. Why wouldn't the military do that?
Right.
I mean, it's anything that can be set up to automatically perform some sort of task. But that said, what are the things that make up a robot? And I've seen different versions of, the characteristics of a robot. The areas there's online there you can look up characteristics of robotics, and you'll find like 5 key elements or aspects of a robot. I'm going to ignore all of those, and I would suggest my own insights onto what it is that makes up a robot. And this comes from my extensive experience actually being the advisor of a middle school robotics club for like 6 months.
If I'm not mistaken,
they didn't have anyone else to do that.
So. This is the one where I think your nephew ended up like winning a competition, though, did he not?
Well, no, that was the one that led him to real robotics clubs,
Oh,
where he
okay.
went on to win competitions.
Okay, so
but,
you guys didn't win the competition.
no, we didn't actually compete. We were, again, this was a middle school robotics club that I was filling in for because the real teacher quit. So, but that said, here's my layman understanding of what robotics is. So there are 5 kind of key parts to a robotic creation, and we'll go through all 5 of what they are. But I'm going to summarize them a little bit conceptually here. And different people refer to these basic things in different ways. But the 5 that I would suggest are elements to act, elements to sense, elements to process, some sort of body or infrastructure, and then some sort of logic. And I'll go through all of those, but any robotic creation that you have is in one form or another going to incorporate those 5 things. There will be something for action, something for sensing, something for processing information, some kind of control logic to determine how it reacts based on that process information, and then some kind of body or structure, you know, beams or wires or whatever, the physical elements that you use to build this thing. And so I would suggest that any robot will have those 5 parts, and we can take them in turn here. But let's start out with action. Any robot has to be able to carry out an action. So what would be an example of an element that a robot would use to act?
Well, we mentioned the robotic arms. So the little pincer things on the end.
Yeah, you could have a pincer.
Call
You
it
could
what
have
you
that.
will.
I don't know. Anyway, you could have the grabby thingy for the purpose of
Perfect.
grabbing thingies.
For the layman, the thingy grabber, if you will.
Yeah, that. So you could have I mentioned manufacturing and robotic arms, welder of some sort, the death ray in the dystopian future that anyway, that we are racing towards.
Yeah, the Tim is currently actually
Yeah,
processing.
exactly. Any of those things. There is some instrument to act, and it can be something that will physically manipulate. Could be something that could translate the robot through space. It could be an instrument of motion. Some people look at action and mobility as separate things. I would submit that not all robots have to have mobility. You can be a robot that is immobile, the robotic arms that I mentioned earlier in manufacturing. But to me, motion, moving the robot around, would be a form of action. Not all robots have the same forms of action. They all have what they need based on what it is that they're built to do.
Yeah,
So,
actually, well, one of the maybe people have read about this already. I actually read about this a couple of years ago, but there is a startup that is trying to create a fully autonomous lawnmower, and they already have ones that essentially follow wires. But this one's trying to take that to the next level and go to industrial scale and be able to map it out in software, be able to sense people. Sorry, I'm jumping ahead, but just another example of different motion. So the robot in this case both drives
let's talk
and
about
cuts
that
grass.
thing. Your autonomous lawnmower. What would be the action parts specifically that make your robot lawnmower be a robot? What would the action aspects be?
I can make my lawnmower be, run by itself. I can just tie a rope to it and put a stake, and then it will just drive around the stake. You know what I mean?
That is true. We will get into sensing and control logic to explain why that's not really a robot, but still something. But as far as a robot lawnmower would go, what would the action part be?
The mowing, the blade.
The
Blade?
shaving of the grass.
Yeah, the thing that cuts the grass, and the power system, or rather the the gears and things behind it. So the blade, essentially. Also the drivetrain to the wheels. The wheels move it around, and any kind of steering mechanism that you have to control its movement. All of those would be part of action for your lawnmower robot. Let's really quickly hit. We'll jump around a little bit. Let's hit the infrastructure aspect. In a robot lawnmower, what would the infrastructure be? I guess I should explain what it is, and then I can then you can tell me. So infrastructure is going to be your physical components of your robot that don't necessarily carry out a function by themselves, but are essential for the overall function of the machine. So your wiring, your body, your spars, your structure, all of these sorts of things, shells that protect all the components. Many of these physical types of things. In the lawnmower example, if the blade is the action, then maybe the gears linking the blade to the engine would be some of the infrastructure. The chassis, the suspension,
Right.
all of that itself would be part of the infrastructure. The actual action part would be, the fact that you have put wheels on it to move. But those wheels do nothing unless they have an infrastructure supporting it, bearings, axles, all of that sort of stuff. You're going to find that in any kind of robotic device. You have to have the robot's body for whatever your robot is. If that makes any sense.
Yep.
All right.
With that, the next thing that sets a robot apart from a lawnmower tied to a stake going in a perpetual circle of sadness forever would be its ability to sense and react to things. And this includes a couple different, actually all the remaining parts of what a robot is. And we'll start with sensing. Sensing is a device that the robot would use to perceive the environment. And based on its perception, it will respond based on those other factors of the logic and processing. But it has to have some way to read, respond, to take input, to read the environment, to feel what's going on around it. And your robotic sensors can come in all different shapes, sizes, and forms, or rather, the real word is phenomenology, but I'm trying to find a layman term for that. Basically, you could have a sensor that is an optical sensor that senses light. You could have a sensor that is a pressure sensor that senses pressure. You could have temperature sensors. Anything that can perceive an aspect of the environment, it can be a sensor. It can. There's all different types. You can imagine. In your robotic lawnmower, what type of sensors would you imagine you would find there?
I guess it depends on how you want it to interact with the environment, to which sensors I would use.
Yeah. Well, if I wanted it wholly autonomous to the point where it could mow the grass with no input other than me telling it mow grass.
Well, then I would want a photoreceptor, an infrared receptor, because maybe you want to mow your grass during the middle of the night and annoy your neighbors. I mean, who knows, right? It would need some kind of GPS to map out your yard and recognize where it's supposed to go. maybe sound, some kind of pressure. I don't know, to avoid rocks.
Yeah, any of these types of things could be sensors you would use in there. You probably have some kind of positional sensor so that it knows where it is, or so that it can determine where it is. You would probably have a series of optical sensors to detect obstacles. Obstacle can be in any wavelength you want, visible light, infrared, ultraviolet, whatever. It all depends on the application. You would probably have some kind of internal sensors so that the robot could determine how close to the ground its blade is based on how far extended the wheels might be relative to the bottom of the lawnmower and how far extended the blade is relative to the extension of wheels. Sensors don't have to be external. They can be internal too. The robot needs to know what it's doing on the inside as well. And so,
Like emotionally.
yes, because if everyone wants to know what is the robot doing, but nobody asks how is the robot doing.
Exactly.
So
We have to start considering these things,
Yeah.
you know?
But no, internally, this is a critical aspect of many machines, robotic and otherwise. But you have to have feedback systems. If I have an extendable jointed arm, for example, I need to know how it's extended, how much it's bent around a joint. So I'm going to put sensors in there that I can use to determine how much my joint has changed. How far something is extended, how all of these types of things. And there's a number of different sensors that you can use for that. Sensors that send different amounts of electrical feedback to a control circuit based on displacement from a 0 point. So if my robotic arm, if the elbow of my robotic arm is locked straight and I say that's my 0, then when I deform that joint and bend that elbow, the little device that I've put in there is going to send a different amount of back to my control circuits based on how much I've bent that joint. And though that will essentially give my robot a cue that something has changed, I'm no longer in the locked straight position. I'm now in an arm bent position, and I know I can determine how far my little robotic arm is bent. So likewise, my robotic lawnmower, it's going to have an optical sensor that will pick up the sidewalk. And it knows that when it starts to see this gray patch of asphalt, that's a sidewalk there, and I need to react to that. Example. That would be, well, okay, I just jumped topics kind of. That's an external sensor. It's also going to have a sensor on each of its adjustable little wheels to know how far deflected the wheels are from its baseline. I'm assuming I have adjustable wheels that react automatically based on hills and things. And so it can level itself out and give you a nice even lawn cut that's not going to look silly because of the bumps and ridges. I don't know. I'm kind of rambling a little bit, but do we understand what sensors are essentially and the fact that you can have internal and external sensors?
I'm more concerned that your sidewalks are made out of asphalt.
Concrete, whatever.
I'm glad that the thing that
My
Cameron got out
sidewalks
of
are automatic conveyor belts that move me forward based on. Oh, never mind.
Matt believes that he shouldn't have to walk; the ground should move him.
Right, robot sidewalks. That can be a thing. It totally
Hey,
could.
they did it in the Jetsons. It's totally plausible.
Yep.
They're planning a community in the middle of a lake that I live near, and they are planning a conveyor belt to remove all the trash in the community to
just dump it into the lake.
Yeah.
No, it's going to go into some kind of tunnel and then dump on the land for the waste people to pick up. But it's part of their plan, so totally plausible. Nice. Why not have moving sidewalks? We have them in airports. Why not all over?
That's right.
Well, yes, why not indeed. Anyway, so that's aspect number 3 of the robot. We've talked about the fact that it has to be able to act. We've talked about the fact that it has to be able to have some kind of physical structure. And we've talked about the fact that it needs to be able to sense the environment. Now, once it senses the environment, is it done?
No.
No. It
No,
has
it-
to react to that. And for that,
Yeah.
you need the last two aspects of a robot. That's going to be processing stuff, and it's also going to be your control logic. And so what do I mean by that? 'Cause this is two separate things. They are related, but they are also separate. Yeah. So when we talk about a processor and a control logic, we're essentially talking hardware and software in terms of its computing ability. One from another, every robot or robotic device has to be able to react to its sensors in order to carry out its action. And in order to react, you need some kind of computing, some kind of processing. And so you're going to have this in two parts. Brain is going to be hardware. That's going to be your microprocessors. They can be as simple or extensive as the robotic application requires. But somehow you're going to have some computer hardware in your robot. In your robotic lawnmower, it's probably not going to be super intensive because, I mean, it's just a lawnmower and you got to control where it is and what it's mowing and RPM. I don't know. Your control logic is going to be the software behind it. It's what you have programmed your robot to do. And that is going to dictate how my bot reacts to things. It's the instructions that I put in place so that when robot senses thing A, it reacts with action B. And when it senses X, it reacts with Y. It is really as simple and as complex as that. Your control logic does not have to be, well, in general, it's going to be custom tailored to whatever application you want your robot to carry out.
Yeah.
But it can be
Which-
very simple, or it can be
Right,
very,
which-
very complex.
Right, which is why fully autonomous anything robotic is the challenge, because as soon as you become fully autonomous, then you have to be able to react, have logic that covers
Yeah.
unknown, essentially.
Right. Up until pretty much now, your control logic is limited by how foresightful your programmer was. You know, the programmer envisions a bunch of different situations and scenarios and basically says, okay, if you see this thing, you do that thing. If you see this thing, you do the other thing. And if you see that thing over there, you do this thing here. And as many scenarios and parameters as the programmer can think of and put in place, that's going to dictate how your robot is going to be able to react to stuff. And it's all dependent on how foresightful that programmer is. Now, with some of the recent advances in AI, we've now started to generate programs that can, well, learn and add some of their own controls based on different scenarios. That is at once pretty cool that we're to that point, and also terrifying because it's only a short step from there until they can not only come for Tim, but the rest of us as well. I am mostly kidding.
Tim was the
But-
low-hanging fruit, you know.
What?
I said Tim was the low-hanging fruit. You know, they got to start somewhere.
Yeah, but
So you're saying the
it'll be
Matrix
interesting
could
to
happen?
see how robotics evolves based on the fact that we can now do more potentially than what the programmer anticipated. And again, that is both very promising and very concerning, because you better have set up your robot with some kind of control logic that will bound what it is allowed to learn to do. You don't want your robot to learn that, hey, I will actually achieve maximum efficiency if I can get rid of the flesh bags, if you have seen Futurama.
Yes, iRobot, if you will, Will Smith.
Not just iRobot, but all of these things.
Oh, they all
It's,
ended in humans
Yeah,
dying.
the
I mean,
robots are not your friend. Wait, no, never mind. But yeah, it's now again, at some point, your robots are only going to be capable of operating within the bounds that their control logic will let them operate in. But what we have seen is people building control logic that can, that can increase its own boundaries in different ways. And as long as there are some hard rules in place, that's probably fine. We'll see a lot of good things come out of that. A lot of really, really impressive things. But that's something to watch for.
You know what I haven't seen that would be interesting, and I'm sure if it hasn't already been done, it will be in the near future. Is you take the MIT robots, the ones that I think we mentioned this before, like 6 months ago or more, the where they have these robots that can essentially like do parkour stuff, where they jump around on obstacles and all that kind of, and add the newest AI chatbot engines to one of those, so you have essentially a functional robot as far as a physical presence and the ability to walk and jump or whatever, that also then interacts with you in a human way, and then you're really getting closer to what you've seen in the movies for the last 100 years.
Yeah, they did a documentary about this. It's called Blade Runner.
Yeah. If everyone just took our word for what is a documentary, every fictional work of
don't
cinema,
take our word for it. Ask ChatGPT. And ask ChatGPT whether or not we need to be afraid of our new robot overlords. But coming back to some seriousness, we joke about these things. There is a lot of hysteria in some circles about potential dangers. I will admit that I am less worried. With any technology, any technology down to the very first rubbing of two sticks together to make fire, humankind can use them responsibly or irresponsibly. Nuclear power is a potentially phenomenal, game-changing way to satisfy the world's energy needs. See our podcast on the basics of nuclear energy. On the other hand, if used irresponsibly, it is incredibly dangerous. See, the basics of Chernobyl, which is a podcast that we haven't done, but we really should do. Likewise, robotics. Robotics in its simpler forms, and robotics in its more advanced, artificially intelligent forms. All of these are potentially extremely helpful, but again, they all just need to be used responsibly.
Yeah, and I'll be interested to see, with these, because you've seen these robots, so I don't know, have you already touched on this? I guess you kind of did it with something else, but just the structure of the robot, the infrastructure, is that what we were talking? Whatever.
Yeah, the body.
Yeah, the body of the robot. Right.
I like calling it that.
Where the where we have something that can walk, something that interact with a physical environment beyond just very basics. Even the robot lawnmower, is very limited in scope, right? It's very much a one-job robot, as is your vacuum robot. Every robot that kind of is in the public domain right now is very much a one-job robot, and that even goes to the point of, if we're including artificial intelligence like ChatGPT, all those types of things, while they are multifaceted in all the ways they can use language, just a language engine, really.
Right.
And so it's the combination of the skills that is going to really open new avenues for use. And so you're taking the MIT robots and putting, like I said, putting ChatGPT on them. But the problem that I've seen, at least the thing that I haven't seen overcome yet, and to be fair, this is learn it from a layman. But
Yes, it
the
is.
the ability that robots have to interact with things like fine motor skills, even the MIT robots from a year or two ago, whenever they made that video of them jumping around doing parkour, the outtakes from that show you very clearly they're still robots.
Yeah.
They weren't exactly crushing it at all times. And so the idea that they could interact with a biological human world in a way that doesn't end with a robot falling off a cliff, I'd love to see it. I haven't seen it yet.
Yeah, we're not there yet, but we are getting there. And
Right.
again, as sensors and feedback systems become more and more precisely capable, more and more accurate, and as processing systems become more and more powerful, more and more advanced, and as control logic expands and incorporates more of the machine learning techniques that we're starting to see, yeah, you will get to the point where these things can do can do more things more naturally looking, or rather, I guess, with less difficulty. If you want to see a really interesting one, General Dynamics and their military robot dog. I made reference to that one. Look it up. Look it up on YouTube. It's a very good boy.
We'll link it on our social media, something we've never done before.
There we go. And, this podcast is not endorsed or sponsored or anything by General Dynamics, nor do we endorse them. But, Robot Dog, go look it up.
So what I'm hearing Carl wants to see is the MIT robot participate in
parkour competitions,
American Ninja
American Ninja Warrior.
Exactly. And then have an interview afterwards.
And then diss all of us while they're competing with ChatGPT.
Yeah.
In 5 different languages.
We had a discussion at work today, actually, about whether or not robots will replace people, and a person I work with was very concerned about that. And I mean, at some level, you talk about robots being single function right now. Well, okay, Deep Blue was a single function chess algorithm, not necessarily a robot because it couldn't act. It just told other people to act for it. But that and other chess computers have already surpassed humanity, guys. We're past that chapter in history where there are already things that computers and robotic machines can do far better than humans.
Yeah.
And again, as with any technology, that is okay if it is used responsibly. And I guess that would be kind of my final thought on all of that.
Yeah, and that's a good point. And I shouldn't undersell. Like when I say ChatGPT is a language engine, I'm underselling it. It is like an ontology. Like it has all this logical understanding. It's not just generating words, right? Even it's. I mean, it can pass the bar test, right? I mean,
yeah.
Like it's more than just generating language, but it is. It's essentially I don't know how to describe it. I guess I don't have a good word for it, but it is. It isn't also, a android that can go out there. It isn't C3PO. Is I guess my point. It can't go out there and, blow up the Death Star.
Well, 3PO didn't do that either.
Droid.
That was R2.
Dang it.
I'm just saying, like my wife, she wrote this 1-page paper for her work, and then one of her coworkers ran it through ChatGPT and asked it to make it sound like Bill Gates, and it rewrote her paper and she was a little offended because it then sounded better than what she wrote.
Oh, yeah.
And but you know, it's out there, you know, and you can have something that will sound much better than you if you choose so.
Yeah.
Yeah.
And, you know, at that point you wonder, well, okay, what's the role of humanity then if the robots can do it better than us? And
That's the next podcast.
That's the next podcast, the basics of computer, you know, AI and robotic ethics.
Yeah, it'll be a good question. It's a way, the best way to leverage the technology, like Matt was saying, is that's the question. Best way to, or at some point, it's the question is going to be best way that robots can leverage humanity.
How can the robots best leverage us?
Yeah, exactly.
Yeah.
So,
well, if the Matrix is to be believed, and I don't see why it wouldn't be,
it's a documentary.
Yep.
Dang it. Well,
isn't that what half of Wall Street tries to do, is come up with algorithms and such to predict the market to make themselves more money?
Oh, yeah.
Yeah. I think even robots are going to struggle with predicting the future. So
I don't know.
I'm just saying.
I feel confident about that. Actually, of the few things I can confidently say on a robotics future podcast, I can pretty confidently say the unpredictability of the future is it hasn't failed us yet. Okay, speaking of unpredictable, kind of. We started, so we have a YouTube channel. We've always had a YouTube channel. Most of our people that listen to our podcast listen on Spotify. We've mentioned that before. We are now actually posting, probably despite our better judgment, the video to go along with our recordings. So if you want to know why this is, for the last few years, only been a podcast, you can now see why it's only been a podcast and why you probably will go back to only listening instead of watching. But it is going to be on our YouTube channel from now on. So in the case that we have, more guests in the future, maybe there'll be a reason to watch. But yeah, that'll be available, and I want to thank all of our listeners. I do think that the Tasmanian listener is once again probably one of my favorite. I don't know that we only have one Tasmanian listener, but we have at least one Tasmanian listener, and that's the important point.
Carl loves you for some reason.
I think it has something to do with
national origin.
Exactly. Yeah. I mean, it has something to do with, like, was it the Looney Tunes, the Tasmanian Devil?
That's
a positive association, is what I'm saying.
There we go. We'll just reduce Tasmania to a cartoon.
Little whirling
We
creature.
should close this one before General Dynamics drops their sponsorship.
Okay.
I'm just going to say I like Taskmaster. I think that's a hilarious show. From
Taskmaster.
Yeah.
Is that
one I'm unfamiliar with?
Based in Tasmania?
Australia, but they do visit Tasmania. I think
Okay.
I think someone's from Tasmania over there.
Oh,
maybe
okay.
Something like that. But it's a hilarious show. I see clips of it all the time. So
I will take your word for it.
All right. Well, thank you, Matt. Robotics, certainly an appropriate and relevant podcast for the current state of the world. But we'll be back again. I already teased an episode. I think we're going to have one soon about mechanical engineering. I've got a friend from San Diego coming on that's going to discuss some of his work. And then I've also got our old friend Mick McGurr, who's a lawyer in Arizona. He came on a couple of years ago. He's going to be jumping back on, teaching us a little bit about the different fields of law.
And how we protect ourselves from saying things too stupid here.
Yeah, he'll give us lots of ideas of how to make sure that we don't get sued. or put in jail, I think. So both important things. But yeah, we'll come back for those podcasts. Thanks again, and we will see you guys next podcast.